In this video, we'll examine whether or not the alternating series whose terms of the form 1 over square root of n converges absolutely, converges conditionally, or diverges. I've written out a few of the terms. We're taking 1 over the square root of consecutive numbers and we're alternating them. The first term is when n equal to 1, and that gives us a minus sign to start off initially, but then the signs will flip-flop as I go from term to term. The first thing we might do is check whether or not the series converges absolutely. So to do that, I'm going to look at the series whose terms are made positive by taking the absolute value of each individual term. That just means the series 1 over the square root of n and ignoring the sign. So the first few terms will be 1 plus 1 over the square root of 2, etc. So we examine this series now, and in fact this is a p series, a power series, 1 over n to the 1/2, and the power is 1/2, and because that number is too small, because p is less than 1, these terms, although they're going to 0, are going to 0 too slowly, and this series will diverge by the p series test. So the series that we're interested in, the alternating series, cannot possibly converge absolutely because the series whose terms are positive is not converging. So what we'll do next is consider the original series and ask whether or not that converges. And in fact, the alternating series test applies to this series. I look at the terms. They're made up of 1 over square root of n. Those are positive numbers. Those numbers are decreasing. If I look at the next term and compare it to the one that came before it, the next one will be smaller than it. So these are decreasing terms in size. And the terms are decreasing towards 0. The limit of the terms is equal to 0. Those are the three conditions that are required of the alternating series test. So by the alternating series test, my series that I started with, the alternating series, converges. Because the alternating series converges, but the series with positive terms does not converge, we say that the series in fact converges conditionally.